We're going to get started on this last component for the tailstock parts here. We've already got our lead screw done, we got our nut done, and our quill modified. So we've got the retainer here that we got to make that's going to be for this bearing right here. 3/4 ID, 1 5/8 OD, half inch thick. And that bearing is going to sit in there like so. And this is the piece that's going to bolt to the back of the tailstock. We've got 4 screws right there. That's going to be holding that piece on. All right, and then we're going to be using this piece right here of 303 stainless steel to machine this piece out right there. All right, pretty simple, straightforward part. Let's go ahead and get started on it. Man, would you look at that half straight saw cut. This wasn't my piece of material. I actually picked this up from another shop in town. 303 should work really good. Good piece of stainless for just general machining. It's a free cutting stainless steel. Good material if you don't have to weld on it. It's not suitable for welding. It's a 1 13/64 drill bit. Our through hole is going to be 1 1/4, so this leaves it just a little bit small. This is our bore for our through hole. That looks nice. It's a super smooth finish. We just want a 1 1/4 hole size through there, and I am at 1 1/4 right there. All right, we just touched the tip of that tool there on the face. Our depth is going to be 687, 11/16. We've got this set at 0 here, so we'll do a preload at 682, give us 5 thousandths to clean the face up back there. All right, 1, 2, 3, 4, 5, 6, 650, 60, 70, 80. All right, right there. That's our. That's going to be our bottom. I'm just going to reset this. I like a little bit of. Once I come up to my 0, I like having the needle where it comes around. Gives me a little bit of stopping room there. All right, that's going to be our shoulder right there. That's going to give us about 25-30 thousandths to come out to our bearing size right there. So I want to cool it down because it is hot from all the drilling and boring there. I'll set up the cool mist on here and let it spray. It'll cool it down really quick. We'll give that a few minutes and it should be cooled right on down. That was about 5 minutes worth of spraying, and we're nice and cold on our part now, so we should be able to finish out our bore here the way we want. Just getting a size with our telescope gauge to see where we're at, and it looks like we're at 595, so I've got approximately 30 thousandths to come out. Take some equal finishing passes here. You want to equalize the pressure when you're sneaking up on a bearing fit like this. That was a cleanup cut. So now we'll take another measurement here and see what we have left. I'll double check it here. And you want to split your cuts into equal measurements. Okay. Let's see if we can split our measurement here, or split our cuts into two. Got 20 thousandths to come out of there. Alright, that should leave us with 10 thousandths, hopefully. I'm going to actually, I want to shoot for 1 thousandths under that because we want a light press fit. I don't want to overshoot it, and if I need to, I can polish it out just a little bit. My goal is to give it approximately a 1/2 thousandths press fit. Yep. I'm exactly 10 thousandths, so I'm probably going to dial in 9 thousandths, and then we're going to go from there. I will double check it though and make sure that I'm getting consistent readings with my telescope gauge. Man, I landed on exactly what I wanted to finish at. That was 624.5. So that is going to give that bearing 1/2 thousandths press fit into that hole. So I don't even need to touch that bore. Perfect. Need to go in there and chamfer it though. Just got a 3/4 bar there with a high-speed tool bit that's been ground for chamfering. All right, we're getting to the easiest part of the whole job here. We got to turn that down 1/4 inch. So we're at 2 3/4. We're going to end up at 2 1/2. We already got a stop set over here on 0. I'm ready to part this sucker off. I'm going to part it off 1 inch wide, and we're going to chuck it back up and face the back side so that we got a good clean face on the back side there. And as always, this lathe doesn't really like parting very much, so we're going to be running low speeds using cutting oil. I'm using a high-speed blade right there that's it's been touched up, got a good sharp edge, and usually when you run low speeds with cutting oil, it does pretty good. So see how it does right here at 65. See, it just does not like it. So we may end up going over there to the Monarch and parting it off over there. This Victor just doesn't like parting off, man. Let's see if 30 will do it. I guess we might be able to get it done at 30 RPM right here. I hate putting that much tool pressure on that blade. If you don't keep it in there, it chatters. Alright, I think we're getting it done now. That's the lowest speed it'll run, 30 RPM. One of these days we'll see about getting into this headstock and checking the adjustments on the headstock bearings and see if they can be adjusted any, and possibly helping this chatter issue on this lathe. Get in there close, I'll catch it, hopefully. Alright, there we go. Good little tip to keep in mind on these drop pieces like this. Whenever you're done with them, just go ahead and keep them marked like it was so that you don't have to remember what grade it was. All right, there's our parted finish there. And so we've got 50 thousandths there. I just measured it with the calipers that we need to come off of our face. So we're going to go back in here to the chuck. And let's see how square I can get this guy. Hopefully it should square up nicely right there. Grab an indicator. Looks like it's within 1/1000ths. So we're going to face it. All right, 963. Okay, there's our bearing housing. Well, that face turned out nice. All we got left is 4 holes to drill in it, and we'll be ready to go. This is just a sample piece that I'm working on, trying to get my coordinates for the hole pattern is going to be. All right, you can see the 4 divots there. That's replicating where the hole pattern is going to be. So what we have is a 4-hole pattern, and the hole pattern off the center is a 1/2 inch each way. So it's 1 inch center to center this way, but it's on a 2 1/16 circle right there. So I was trying to figure out where exactly it's going to intersect the bolt circle at. So I just worked my way off the center line, went 1/2 inch each way. We're on 1 inch centers there. Just using my digital readout there. So looks like we landed on 900 thousandths on the X axis. And of course we're 1/2 inch on the Y axis each direction. So that's putting us right there. And then we got the caliper set at, well, it just went off. 2 1/16 right there. So we should be good right there. That should be where we need to be. It's just a little piece of drop that I had on the shelf, and scratched that circle in there and found the center, and just trying to get my coordinates. So I'll just take this and I'll just write this down, and then when we do our actual workpiece, I'll know exactly where I need to go to do the 4-hole pattern that we're looking for, just like that right there. All right, we're still centered up on our nice 3-jaw low profile chuck here. And what I'm going to use is my chuck parallels right here from Edge. These are the 1 inch height parallels. And this will allow me to space it up. Alright, and then I'll still be able to rotate these around, you know, just to clear the drill. Wherever we end up drilling the hole, I can rotate those around, but allow it to have a stop to push against as the drill is working there. We're still centered up, but I want to go ahead and sweep the bore of this and just make sure that we are still good on center. Looks like we're getting 1/1000ths. Got 1/1000ths difference there. I'd call that good enough. I'm going to go ahead and spot in our 4 holes and make sure they're right. I showed you on a previous clip there where we figured out where they're going to be, and the reason why he's putting them in that position like that is just because of the way that the tailstock is cast. It's going to be lined up in this area right there, and bolted up to that location. So we're on 500 and 900. So, all right, there's that one. Looks good. See, we're on our 2 1/16 circle. working against the stop and just running the knee up. Just about there. That's looking good right there. We got our stop set, so now we can do all four equally. Alright, all we got left to do is deburr the bottom side of the hole and clean up, and we are done. All right, there's our retainer finished up, looking like the one on the print there. Got our bore complete for our light press fit on the bearing. I'm not going to press that in there, by the way. I'm going to let Brian do that. And then we've got our holes drilled, countersunk. So that those hole locations can be transferred onto the back of the casting, and then he will be drilling and tapping for those 4 hole locations right there. So that is that's the last part for all of the components I got to make for this little tailstock. I'll pull them all over here so we can get one final shot with all of them together. All right, there we go. That should be everything. We got our quill with our nut, Acme nut already bolted in there, ready to go. And nothing wants to stay there where I want it to be. There we got our lead screw that we machined per the instructions that Brian wanted. And then we've got our retainer there that we just completed. We'll get a little bit of a look at how this all goes together here. All right, that's going to go there, and then this housing is going to be there. Of course, it's going to be pressed on there, so it'll be about like so. And you got your hand wheel behind it, and then a nut that holds it all on there. So it's been an interesting little project, and I was happy to get it done for Brian, and I hope you guys have enjoyed following and enjoyed watching. Maybe some of you guys got a few little tips and tricks out there, guys that are still learning the manual work. And that's going to be it. So we'll see you on the next job, okay?